up to this point, we've worked with some very small data sets. This example, we have a larger data set. We have 50 members of a football team, and we have the heights of these players. And so we have one player height 68 inches, 4 players height 69 inches, 8 players height 70 inches, and so forth. There's a total of 50 players. So the total here is for the second column is 50. This is oftentimes the count is also called the frequency, and represented by the letter F. X often represents the value of the variable, so the total is 50. So we can. It's a bit more challenging to try to compute statistics for a larger sample, so let's first start off with the quartiles, it's going to be, you don't necessarily have to write these out, but it may help to write these out, it may help your intuition. So I'm going to write these out. So there's one player of height 68 inches, and 4 players height 69 inches, 8 players height 70 inches, 10 players height 71 inches, 8 players height 72 inches, 5 players height 73, 4 players height 74, 3 players height 75, 2 players height 76, 2 height 77, 2 height 78, 1 height 79. So let's just count these, make sure I got everyone. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Oops. I think I got 51 there. So we have 1, 2, 3. I think I have an extra 71. 1, 2, 3, 4, 5, 6. So an extra 71. Okay, so okay, so let's actually start with the median. The median is there's 52 players. 50 players rather, and half of 50 is 25. If we try 55 from the bottom and 55 from the top, we'll get the median. Let me put my red pen here. Oh, here it is. Okay, so you go 25 from the bottom. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And if we do 25 from the top, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 21, 22, 23, 24, 25. Okay. This would be the second quartile, or it's also called the median. It's going to be the average of those two numbers. So the median is 72 inches. Okay. And then if we take the numbers, so we're going to count the 72s on the left to be less than the median, even though it's a tie. 72 is on the right to be more than the median. And if we take first do the lower 25 numbers and do the median of those. Half of 25 is 13. 12.5 rather, 12.5, which we want to round that up to 13. So we want the 13th from largest to smallest, or from smallest to largest. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it'd be the 70 here. If we count from the largest, it'd be 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. So it's the 13th, so that'll be 70 inches. So that's Q1, and that's 70 inches. And then the Q3, there's also 25 there, and it'll be the 13th from either the middle to the top, or the top to the middle. So it's 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13. Or if we count in this direction, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's going to be Q3. That'll be 74 inches. So you can actually do this without writing all these out like this. For Q1, that's the 13th number, so we just add the counts until we get to 13. 1 plus 4 is 5, plus 8 is 13, that's in row 70. So that means 70 is Q1. And if we keep on going, this will be the 25th. Q2 will be the 25th. So we're up to 13, 10 more is 23, and 8 more is 31. That puts us over. That's in row 72. So that means Q2 is going to be 72 inches. If we count from the top, 13th from the top, that'll give us the highest. From the highest, that'll give us Q3. 1 plus 2 is 3, plus 5 is, plus 2 is 5, plus 2 is 7, 10, 14. 14 puts us over. That's in row 74. So you can get that without writing these out, but I think writing them out like that it helps your intuition. And then we can also use some shortcuts for computing the mean. Normally you'd add up all these numbers, divide by the number of numbers for the mean, 68 plus 69 plus 69 plus 69 plus 69, etc. But 69 plus 69 plus 69 plus 69 is the same as 69 times 4. So that gives us a little shortcut there. We can just multiply the frequency column times the height. So it's 68 times 1 is 68. 69 times 4 is be 276. 70 times 8 is 560. 71 times 10, 710. 72 times 8, 576. 73 times 5 is 365. 74 times 4 is 296. 75 times 3, 225. 76 times 2, 152. This will be 154. 156, 79. And then we want to add these up. The total here is 3617. So X bar is going to be the total divided by the number of players. So the sum of the heights divided by the number of players. So it's 3617 divided by 50. That'd be 72.34 inches. So the mean is 72.34. And then we can go on to compute the variance. Each score minus the mean. So 68 minus 72.34 is negative 4.34. And then we want to square that. That gives us 18.8356. And then multiply by the frequency of the number of players. And that's times 1, so it's 18.8356. Okay, this will be negative 3.34. Square that, we get 11.1556. Multiply by 4 players, we get 44.6224. 70 minus 72.34 is negative 2.34. Square that, we get 5.4756. And then times 8 players, 43.8048. Negative 1.34. Square that, we get 1.7956. Times 10 players is 17.956. Negative 0.34. Square that, we get 0.1156. Times 8 players, 0.9248. And then 73 minus 72.34. Now we're above the mean, so we're getting positive numbers. 0.66 squared, 0.4356. And then times 5 players, it's 2.178. 1.66 squared, 2.7556. Times 4 players, 11.0224. 2.66, square that, 7.07. Times 3 players, 21.2268. 76 times 2, okay, we already did that. This is 3.66. Times 2 players, squared first, and then times 2 players. 3956 times 2 players, 26.7912. 4.66 squared, 21.7156 times 2 players, 43.4312. And 5.66 squared, 32.0356 times 2 players, 64.0712. The 6.66 squared, 44.3556 times 1 player, 44.356. The total of this last column is 339.22. Okay, so then we can use that to compute the variance. So S squared is the total of that last column divided by n minus 1. That would be 49 players. And that's equal to, let's see, 39.22 divided by 49, 6.922 something. And then take the square root of that to get the standard deviation. So I'm going to store this in memory. So sto equals second square root, second recall equals 2.63 something. 12293. Okay. Okay, so that's that. Now there is a way of checking your work on the scientific calculators. The TI-30X2 in particular has a statistics program, and what you want to do is using the stat program on TI-30X2 calculator. You want to push clear while holding on. And then clear. And that will clear out any data that's already in there. And then you want to push second data. And when you push the second key, the second function for data is the stat program. And then push equals, and then data again. So if you do, so push, hold down the on, push clear, and then second data. I'll say one variable or two variable. We want one variable. Next week we'll be working with two variable statistics, and then push equals, and then data again. I'll say x1, so that's our first value. That'd be 68. Down arrow, and I'll ask for the frequency, which is 1, and down arrow 69, and the frequency is 4, down arrow. So I'll put in 68, and then down arrow, and the frequency is 1, down arrow, 69, down arrow, frequency 4, down arrow, and so forth until you get all the data in. And then so I'll continue doing that. So I'll put the rest of the data in. So 70 down arrow, 8 down arrow, 71 down arrow, 10 down arrow, 72 down arrow, 8 down arrow, 73 down arrow, 5 down, 74 down, 4 down, 75 down, 3 down, 76 down, 2 down, 77 down, 2 down, 78 down, 2 down, 79 down, 1 down, and then once you have everything in, you want to press stat var, and so I'm pressing stat var. I'll say n is 50. That's the number of players, and then you push the right arrow. We'll give the mean, which hopefully is the same mean we had before. Yeah, okay, that's good. 72.34. We're good. Now, if you do make a mistake, you can. There is a way of going back without typing in the whole, redoing the whole thing, and then push the right arrow again. You get the standard deviation SX, which is 2.63. Yeah, it looks like the same thing we had before. 2.6311329293. So that's what we had before. You can use that as a check. Now, if you want to go back to the variance, while the standard deviation is showing, you can push the x squared key. and equals. And you have to do that while the standard deviation is showing. So push x squared and then equals, and that gives you the variance, 6.922 something. 857, 143. Okay, and so that concludes this presentation.